Okay, let's do a little real quick math. I didn't really plan anything, but we'll just try to make this real quick and simple. So that means it's probably going to be a 5-minute video. First of all, you have to keep in mind what you're testing. All right. Batteries, solar service. All right. These all directly relate to power, but they're all tested different. So let's just take general understanding of what's going on. Creating power or giving you power, holding you power. Okay, so of course they're going to be tested differently. We'll just make this about solar panels real quick. So first of all, wattage is voltage times amps. Okay, so in this particular case, you got 120 volts and you've got 15 amps. You've got 1800 watts. You probably see this on power supplies all the time. You got 1800 watts. Okay, or not power supplies. You probably see this on power strips all the time. And you also probably see this one as well too if you do any pro audio. All right, 2400 watts. If you do pro audio where you have 20 amp circuits, or maybe even on your welder, you see this before. So wattage, I'm assuming what you're thinking is that the manufacturer is recommending a 10 watt panel and you have a 20 watt panel. So half of it can be covered. And unfortunately, you don't understand how solar panels are designed with a series parallel configuration in the solar panels. So covering one doesn't just mean that you're covering that cell and therefore you're not just getting that power. You're also affecting anything that's wired in series to it. And you'll probably see this in batteries as well too. So if you have a battery configuration that's parallel and series, you might have a situation where you could cut one battery and it affect 3 or 4 batteries down the line. But let's just talk about that real quick. Solar panels are very, very, very inefficient. All right. So we have to do everything that we can in order to make sure we get as much power out of it as we can. So we talked about this before, which you didn't agree with. So SOPI, which is size, and this is generic because size doesn't necessarily always, or actually it doesn't equate necessarily to power. When you're comparing across the same line with the same cells and the same manufacturing, in general it does. So the bigger the more cells that you have, the more power output. However, you have manufacturers that have processes and installation and surface material, all that stuff can actually add more power to the same equal number of cells that you may have in another panel. So you have size, you have orientation, or angle, position, and or you're screwed. Okay, and we also talked about the $100 bill test. So we'll talk about that real quick. I'll just put it over here so I don't forget. $100 bill test. You can call it the business card test, whatever the case may be. So size, we'll just say generically, we'll say the bigger the size, the consideration of more output. Doesn't necessarily mean more voltage, doesn't necessarily mean less voltage, because you're doing a series parallel configuration. So you can have a panel that's this big and put out 60 volts, and you can have a panel that's huge and put out 12 volts. Okay, so size in general for our purposes, because we're generally buying the manufacturer's panels. Orientation, and that's what I explained to you, which you disagreed with, which is a panel that is like this facing south is not as efficient as a panel facing like this south. Granted, all things being equal, because as the sun goes over this panel, it has more cells exposed to the sun. Okay. Now, again, I said test that just to make sure, because you could have some design that's not necessarily true. These are things for you to be, for you to consider, not for me to be actual right. And we're already at 5 minutes. Angle. So in general, we want about a 45-degree angle. A 15-degree angle is not acceptable to your suggestions for the geographic area that you're in. You're going to need to be at approximately a 45-degree angle. You could give or take a few degrees depending upon who you talk to, but it's basically the arc of the sun or position of the earth, however you want to look at angle. And then so size, we'll just make this size. Orientation, we already said this versus this, right? So size, bigger. These are size. These are orientation. Angle, we'll just call this the bracket, right? This is the solar panel. Position, which is another thing that after looking at your picture was the biggest cause for concern, which is obstructions. All right, so you need to make sure you have it in the position where there is zero obstructions. You can't have any obstructions. 0.0, none. You can't have any obstructions, okay? So position is important. I have installed or serviced, and I'm sure I probably installed as well too, where the cells came all the way out to the edge of the frame on a solar panel like this, and just that bottom lip was covered up by a brick column, and we had a solar panel that did not work. In full sunlight, it was putting out 30 milliamps of current, but guess what? It was also putting out 20 volts, which is why voltage is not something you are testing. All right, I test it anyways because what I want to make sure is that the panel is labeled right, but I'm not testing it to make sure that it's putting out enough power, because without the current, short circuit current, right, which we may or may not talk about, short circuit current being correct, if this is correct, you don't have to worry about power. You cannot have this be correct and not have the correct voltage. It doesn't happen. Current is a result of work being done from voltage, which is why the old adage, it's not the volts that kill you, it's the amps. It's the stupidest myth ever, because you cannot create amps. You can only create voltage. You could get amps out of something by putting a load on it, but you can't create amps. You can only create voltage. So position, so angle, and then position, like I said, you have a solar panel like that, you block the bottom of it, guess what? You are fucked, okay? Now, let's get back to that soapy we talked about. Now let's talk about the $100 bill test. This is your solar panel, right? Take a $100 bill, put it over that solar panel. If you have that much blockage, and sometimes you can have just the size of your finger, right? You can have the size of your finger block this solar panel, depending upon where you block it, depending upon the solar panel, and that solar panel will be effectively dead in full sunlight. I'm saying this not to be a dick to you. I'm saying this so you don't waste money. That's it. It's not for me to be right. I want you to prove me wrong by testing this stuff. So it is not about me being right. I am doing this because I got pissed off at manufacturers telling me that test the voltage, test the voltage, test the voltage. You can have all the voltage in the world, no current. So voltage does not matter when we are testing this. Okay, voltage is not important. The reason why we're testing voltage is not to determine what the voltage is to make sure the power is the voltage is correct for the application that we installed it on, that we didn't get a 24 volt panel or a 36 volt panel, something like that, and we needed it in a 12 volt or a 24 volt situation. So again, solars, we're testing it different than this. From our incoming service, solar and batteries, these are all three tested different ways. We got one that holds, two creates, so they've got to be tested different ways. So if you put that $100 bill, and sometimes even smaller, over that solar panel, be it a leaf, a trampoline, anything, you are screwed. The solar panel is not effective. So now we're going to get back to the mistake that you just made, and I don't want other people to make it as well. is that is the watts. Well, I've got a panel that's got 20 watts on it, and I only need 10, so you didn't say this, I'm just making this up, so I can have half of it covered. It is the biggest mistake that anybody could ever say other than the stuff that you've already said. All right, so again, we've got 3 different things. Service, all right. Man, call me. I will help you out with this. Brian Davis mentioned it. I showed Brian Davis how to test short circuit current on the back of his truck, and it blew him away. How I could just put a couple of fingers over that solar panel and render it effectively. All right, so now here, real quick, what do we have? We have, in order to determine watts, we got volts times amps, and that equals watts. Okay, so in that solar panel, most likely in full sunlight, you're going to have 21 volts. And I'm going to get my calculator here real quick so we can be exact. Now, what you said was, this is what you said because I asked it. I said, what did you test the short circuit current at? And you said 1.5 amps. And what that puts that at is, let's see, sorry, I was going to try to do the math, but there's no point in doing it when you're trying to prove a point, or somebody goes, you didn't add, man. I told you he couldn't add. He's an idiot. Well, an idiot is true, but let's not do that in this particular case. So your watts is 31.5, okay? Now, granted, this your voltage probably is 18 or something like that, but if you saw 22, 23 volts on a fully sunny day without a load on it, that's exactly what you would get, is you would have 31.5 watts. Now, you didn't get that. I know that for a fact. You and I both know that. Again, you're saying I've got a 20 watt panel and all I need is 10 with it half covered. Again, I'm saying that part of it, but you're just saying that you have double the wattage. Well, your math doesn't work out. I guarantee you, and I'll bet you, let's just say 20 bucks. All right. I'll bet you 20 bucks, 6-pack of beer, and you're from Texas, I'm from Texas, so it's got to be some good beer like Coors Light or something like that. I bet you 20 bucks that if you go out there, replicate those exact same situations, full sunlight, okay, go out there on a cool day because it'll actually be more efficient. Full sunlight, that post covered up that panel, I will put money on it that you will most likely get, I'm going to say, 500 milliamps, okay? Oh, you can't even see that little magic with numbers. So, if you have 21 volts and you have 0.5 milliamps coming out of there, you get 10.5 watts. Well, you said you only need 10 watts, so that's that, right? The other thing you have to consider is that the equipment, so Patriot solar panel is going to turn, the charge controller, if I remember correctly, charge controller turns off at, well, it doesn't equal to, but turns off at 250 milliamps, okay? So if you've got anything else hooked up to directly to the battery, you've got a LiftMaster receiver, you've got any kind of accessories, again, going directly to the receiver, not to the battery, or it's going directly to the battery, not to the control board, because to the control board, it doesn't affect it. Even though you will lose power through the control board, we're talking specifically about the charge controller at this particular point. All right, now, my contention is that you will have, I'm sorry, I made a mistake. I was wondering what my numbers are. So this number is right, okay? So you are probably going to meet just the minimum requirement of what you need in full sunlight, full efficiency, okay? So that's only just a couple hours out of the day. I made a mistake on this calculation because what I meant to say was 50 milliamps, not 500 milliamps. And I may have said 50 and then wrote 500. So that math is relatively simple. You got 21 volts, which is probably about the highest that you're going to see. So that means you have effectively a dead panel, which is 1 watt. Okay. So anyways, look, man, this is not to be mean to you. It is because I'm pissed off that our distributors, our manufacturers, the teachers that don't know any better, that don't know how to actually use current on a handheld multimeter are teaching us the wrong shit. This is not about you against me. This is about us against small business entrepreneurial problems. I'm trying to save you a warranty call. And guess what? When this right here, when this goes bad, you're going to have what's called more than once sulfation on those sealed lead acid batteries, right? You're going to have sulfation on that as we continue to charge this battery down, and all of that equals is a new battery and more warranty service calls. Jesus Christ. So just keep in mind, these all three are tested different. Solar panels are tested different than these two. These create power. This holds power, even though you can actually see the power increase off of this after a load. When we're talking about watts, golly, you tell it's 7 o'clock at night. Watts is volts times amps. So the volts that you actually are testing at the solar panel, and the worst solar panel that you could buy off of China in full sunlight, that's a 12-volt solar panel, will always have 1821 volts, sometimes even more than that. Voltage is not what is to be tested on a solar panel. If I were going to test anything, and voltage was one of them, it would be the last thing. And again, all I'm doing is verifying that I have a panel that has the right voltage for the situation, not is the voltage there. If I have correct short circuit current, and that's what I'm going to test first. First of all, I'm going to test my meters, my probes, my leads, my fuse, and then I'm going to test what my short circuit current is, and it needs to meet or be close to in full sunlight of what this is. And a 20 watt at 1.5 amps is going to be more than enough power for that charge controller to put out 1.5 amps and start charging your battery properly. So this is just the math, right? Way I'm saying it may sound like a dick, but you can't beat this math. If you could beat this math, if you could prove me wrong, please, you got a 6-pack of beer. I may even promise a 12-pack of beer of something good. It's got to be Coors Light, and $20. Go back out to that and test your short circuit current and prove me wrong. Please do, because I am teaching it the wrong way if you're not right. But you cannot and you will not ever beat or screwed. If you don't pay attention to Soapy, you're going to be, if you don't pay attention to soap, you're screwed. All right, which is Soapy. All right, man, call me 214-931-2626. We'll work through this together. But I don't want this to cost you $300, man. I do not. That's what a new battery and a warranty call is going to cost you. And then you still have to fix the problem. On top of that, potentially losing a customer. All right, man, thanks.